Hey everybody, this is Games Plus James, and today we're going to take a look at how to add parallax scrolling to your 2D game. So what is parallax scrolling? Parallax scrolling is basically a way of creating depth in a world by moving objects in the background. So it makes it look like things in the background are further in the distance, basically. So if I just play my little game that I've got set up here, I've just got a basic little 2D platformer type thing going on here. We've got this little guy, and at the moment, the world behind him, it looks fairly flat. Everything is moving along just as he moves. It kind of looks like it's just a painting on the wall behind them. So it's not really very interesting or very engaging. As we walk along, it looks kind of a bit bland, and it makes everything look even more 2D than you kind of want it to look. So I'm just going to stop this here. And basically, what you want is the items in the background to be moving around, so that it looks like it's giving you a sense of depth behind the player. And this parallax system, it'll work for any kind of 2D game that you want to add depth to it, really. Not just 2D side-scrolling things. If you've got like a space shooting game, you'd be able to use this system to create depth within space and stuff like that. So what we're going to do is basically we have, as you look here, we've got like 3 separate layers of mountains. And what we're going to do is create some depth with these mountains. There's other ways to do it. Kind of awkward almost way to do it within Unity is if you get your main camera, and if you grab the projection here and change it from orthographic to perspective. If we just zoom this back in a bit, so there it looks perfectly fine, but it looks normal. But what we'll do is if we go from 2D to 3D here and just kind of turn the camera around and move it over and move it to here, just so we can see. So if we move some things into the background a little bit, so say we just grab our sky out of the way, but say the distant hills, if we move them back, the middle ones to there, and these guys there, you can see they're getting smaller in the view. But if we play the game, it'll create the effect we're kind of after to a certain extent. So if we run our guy, so we can see we've got a little bit of depth going on here now. The things in the distance are kind of moving around a bit. But the awkward thing with this is to adjust the depth of stuff. Yeah, you can move it back behind into the distance, but things are going to get smaller and smaller as they go away from the screen, and that's not very ideal, because then you're messing with different scales and stuff. Say if, for example, you're using a pixel art game, suddenly all your pixel art will be at different sizes, and it won't look good to the player. So instead, we're going to use a system that moves the items around in the world for you. So let me just reset the camera here. Put this back to orthographic, just like that. So there we go, we're back to our flat world. And we are going to use the different positions of these things to make it, to control where they are in the world. So I'm just going to set these up. So we're going to set our furthest hills, we're going to set them to a distance of 10 away from the player. You don't have to use these distances, you can use whatever you want yourself. But the middle one we'll set to say 6, and the near one to about 3. So now they've got a certain amount of position in the world, and we can move them around and get different effects by moving them once we have our parallax system in place. And the parallax script that we're going to use is very simple. Basically, all it's going to do is, as the player moves along, we'll just go back to 2D view here. As the player moves along, it'll just move the mountains behind them, and it'll reposition them and make it look like there's a bit of depth going on for the player. So what we need to do is create a very simple script. So we're going to go here, create a C# script, which we're going to call parallaxing, if I could spell it properly. There we go. Parallaxing, and we're going to open this up in MonoDevelop here. Once it gets going, there we go. Okay. Oh, no, we've gone back out. There we go. Okay, so we're going to need a few variables to start off with. Basically, we're going to need to be able to reference the individual layers of stuff. So what I've got is basically, so say on these hills here, I've just got a whole bunch of items that are just copies of the same thing pasted along. But what we want to be able to access is, rather than those individual ones, just the overall game object that is contained in them. And the same for the middle hills and the far hills. And you could have as many of these hills as you wanted, really, in your own game. So what we're going to do is use a public transform array. So this will be an array of transform positions, which is what is holding all those background items. So we'll call this backgrounds. So that's going to be our transform array of backgrounds. And what we're going to need as well is the amount of movement that each item is going to, or each background element is going to move by. So we want our mountains in the distance, they will actually be moving the most, but to the point of view of the camera, they'll be moving the least. It's kind of counterintuitive when you just kind of look at it that way, but once we have the system moving and in place, you'll see it's very kind of, once you see it in action, it's very sensible. So we're just going to say private float, and again it's an array, and we're going to call this parallax scales. So this will be the amount of movement for each layer that is moving as the camera is moving. And we're also going to use a value called a public float called smoothing. And smoothing is basically just going to be a value that we'll use to determine how much the how smooth it looks as the camera moves along, and how quickly the background moves along behind us. And again, we'll see it in action once the game starts running. So in our start function here, there's one more thing we need. We'll need to know, so as the camera is moving along through the game, we're basically going to move the backgrounds based on where the camera was previously to how much it's moved to where it is now. So we'll need to know where the camera was on the last frame when it updated the game. So we're going to say a private vector tree here called previous camera position. So that'll be the last position that the camera was. So once the game starts, at the very first moment, we'll need to immediately say, okay, the previous camera position is equal to the current position of the camera. So this script will be attached to our camera, so we know it's the transformed position of the camera. I'm just going to save this. I'll just convert that. Sometimes that happens. I'm just going to add this onto our camera now, so I remember. The only thing I've currently got on the camera is a very simple script just to follow the player. So we're just going to add this parallaxing script here, and I'm not going to worry about any of the values just yet. So there we go. We've got our transform.length. So our parallax scales, it's a private object, so we're not starting off with anything into it. We need to determine what our parallax scales is. So we'll just fill in some of this thing here. So we've got our backgrounds array here, and that's going to be holding our different hills layers. So we're just going to drag them all in here now. So we've got our near hills and drag that onto there. Just drop this down here. Our middle hills, which will drop there, and our far hills finally, which will drop there. So now we've got our 3 different hills. So back in here, we've now got our backgrounds array filled up, and we need our parallax scales, which is going to be based on how far they are off into the distance. So again, if we go back to 3D here, we've got our 3 different layers set up at different positions in the background. So we've got our near hill is a 3, middle at 6, and our far at 10. So we know that there's a certain amount into the background, and our parallax scales is going to be based off how far they are into the background. So now that we know, say once the script starts running, we know that our background has 3 objects in it, so we need our parallax scales. We need to have 3 different parallax scales. So while our parallax scales is set up initially here, it hasn't got any values into it, so we need to make sure that it's the same size as the amount of backgrounds that we have. So here we'll just say parallax scales is equal to a new float array, and the size of that array is backgrounds dot length. So that's the length of our backgrounds array, which is 3, because we have 3 objects in there right now. But of course, like I said, if you had like 20 layers of background stuff, you could have that there, and our parallax scales would then be 20 layers or 20 objects in the array. So now that we know how big our array is, we need to go through that array and determine what size each of our parallax scales should be by how far these things are into the distance. And the way we do that is just by using a simple for loop. So our for int I equals 0, while I is less than our parallax scales could be spelled right, parallax scales dot length, and then I plus plus, so I is incrementing. And then within this loop, very simply, we're just going to say parallax scales I, so the position that we're at, so starting 0 of course, and then 1, 2 and 3, or it's just 1 and 2. Parallax scales is equal to backgrounds I, so the same object in our background array is what we're looking at in our parallax scale, and we're just saying the position dot z, and we just have to multiply it by -1. And that's just for the purposes of how our system is going to work. So next thing we're going to do, basically that's all we have to do in our start function. So now once the game runs, if we'll just have a look here, just let that compile in the corner, and I'm just going to hit play just to demonstrate that it's working, because you always want to check and make sure that once you start doing stuff that that's all working fine. So on our camera here, we go down to our Parallax scripts. We've got those 3 things. If we switch to debug mode here, and scroll down again, now we can see our parallax scales here, and if we pop it open, there we go. It's got the values that we wanted, so -3, -6 and -10. Perfect. So we'll just switch back to normal and stop this running. Okay, so now we need to update things as the player moves, because as it stands at the moment, we're still not doing anything with the objects. They're just standing still and not going anywhere. So rather than using the update loop, because the chances are whatever you're using to control your camera, it will be moving more than likely in your update loop itself. So what we want to make sure is that our parallaxing is happening after the camera has already moved. We don't want it to be doing our parallaxing to be sometimes happening before the camera moves and sometimes after. That means that way we'll end up with jerky movement all over the place, and that's not very good at all. So instead of doing it in update loop here, we're going to use the late update, which basically in the order of things just happens directly after the update function happens. So what we're going to do here is basically loop through the backgrounds array, and for each one just move it a tiny little bit compared to where the camera was last time. So if the camera last time was at, say, an X position of 1 and now it's moved to an X position of 2, then what we're saying is, okay, there was a movement of 1 there. The first background we need to move a tiny little amount. The second background we need to move a little bit more, and the third background we need to move a little bit more again, based on our parallax scales. So we're going to basically loop through our array of backgrounds. So again, we'll just set that up very simply. Is just an int I equals 0, and then while I is less than our backgrounds dot length, I plus plus to increment it, and there we go. That's our simple little loop setup. So the first thing we need to do is determine how much we're going to move in each moment. So we're going to just create a new a vector tree object called Parallax. If I could spell that right, there we go. So this is just going to be a vector tree object with an x, y, and a z value, or z position value, and it's just going to say, so where the camera was previously, which is our previous camera position, we're going to take that position, take away the current position, which is our transform dot position. So we're going to take those values and we're going to multiply the amount of movement that we had. So say in general the movement will be like 0.1 something like that for each one of those things. For example, we're going to take that value and multiply it by our parallax scale. Parallax scales, and the current one we're using is, it'll be our I int value. So we're going to multiply it by our parallax scale. So say that'll be -10. So our new movement will be say -0.1 multiplied by -10. So we get our -1 movement amount. And we're going to multiply that by our parallax scale, and then we're going to divide our parallax scale by our smoothing amount. And our smoothing amount is basically our control for how we can adjust it to get a good balance of what we want going on. So our parallax amount is our previous position minus our current position multiplied by our parallax scale that we're using for this current object, and divided by the smoothing amount that we want. So then what we're going to do is create another vector tree that we're going to call our new background position. And this is going to be the position that we're going to be moving into in a second. Actually no, rather than creating a new position, that was the way I've done it previously, but we can just directly say, instead of that, we're just going to move, so our current background that we're wanting to move will be our backgrounds I dot position. So that's the current layer that we're looking at moving, is now equal to a new vector tree. So our vector tree has an x, y, and z value, so we're going to have to move our x, our y, and our z. So we're just going to say, take the current position, so backgrounds I dot position dot x, and add on, now that we know how much movement we want to have with our parallax vector, so we'll just say our parallax dot x. So the x value from our parallax, we're going to pop that in there, and we're going to basically do the exact same thing for our y position. Just going to grab that and paste it in again, and just change x to y, and here our parallax dot x to parallax dot y, and then finally we're going to paste it in one more time, and our z position won't ever be changing. We don't want to mess around too much with that, so we're just going to get rid of the x there, and we're not going to add the parallax onto our z value because there's no need for it. So now basically what we're doing is, on this line we're working out how much movement we need to happen based on our parallax scales, so based on how far they are into the distance, and our smoothing amount, so that we can control how quickly everything is going to be moving. And then we're taking that value and we're just adding that on to our current position for each individual layer as the for loop cycles through. And finally, once we finish cycling through our loop, what we need to do before the whole frame animates on to the next section, to the next frame even, what we need to say is, okay, so as we're using our previous camera position every time to work it out, at the very end of the frame we want to say our previous camera position is now equal to our current position. So that next time around we're using an updated previous camera position every time. And if you don't do that, you get some pretty weird stuff going on. I'd recommend trying it out just to see what kind of strange things happen. You never know. Sometimes when you mess around with this kind of stuff, you get interesting ideas for things that you hadn't previously thought of. So now we should see, we just switch this back to 2D, and it's going to maximize this once we start playing. So we're going to play the game, and now we should see a little bit of movement going on in the world behind us. So we're getting a strange error here. Hold on. Why is it causing an error? Okay, that was only a brief couple of seconds for you guys, but I just spent the last 10 minutes trying to work out what was going wrong with my code, when I eventually managed to realize that the problem is my smoothing was still set to 0. I'm going to set that to 10. So obviously if you divide by 0, you're going to end up with some problems in your game. So yeah, make sure you change your smoothing value before you start running the game. So if we press play now, we should get something much more sensible happening. Hopefully no more errors. There we go. So now as we walk along, as you can see, now it looks like we've got a bit of depth behind us. Our mountains in the background there are moving nice and slow. If we, sorry, just make this full screen here. Our mountains are moving nice and slow, but these guys are moving at different speeds. So now we get a nice little overlap effect. And if we jump up, we get a little bits of gaps appearing behind us as well. So now it looks like we've got some actual fun things happening with our background behind us, and we can adjust their values a little bit. If we play around with the smoothing, we get some different stuff happening. We'll just set this to 1 here. So as you can see, we set it to 1, we get crazy amounts of movement happening. If we set it to say 20, that looks a bit more sensible. Set it to 50. Things move a lot slower then. So it's kind of down to your own kind of preference, which way you feel looks best for your game. It's an interesting thing to play around with the different depths, and say if you feel that these mountains are moving at a nice speed, and these mountains in the middle, you feel like they kind of feel a bit too. The mountains in the background are barely moving, and these guys are moving a bit too fast. So we'll grab our middle hills here, just switch this back to normal again, and we'll put this value up to say 8. And if we stop and run the game again, because of course our parallax scales are being worked out straight away, so we need to we need to set it before we run the game. So we run it again. We can run along, and we can see now they're moving a little bit differently, and maybe it kind of feels a little bit better, if I'm honest with you. So yeah, that's basically how our parallax system works. And if we keep an eye on what's going on up here now, as we can see, as we're moving along in the game view, it looks like the mountains in the background there are they're barely moving at all. In fact, they kind of look like they're not moving. Let's put this up a bit. There we go. So now it looks like they're moving a little bit. But they're not moving a lot relative to the player. But if we look in the game view here, what's going on is they're being moved quite a bit to catch up with the camera. Our middle ones are moving a little less, and our close ones are moving even less than that. So what's happening is, to achieve the parallax effect, basically what you're doing is moving the background items close to the speed that the player is moving. And the closer they are to the speed of the player, the more it looks like that they're in the background. So if we set this back to 10, what we're having at this value is our object that's set to a distance of 10 is moving the exact same speed as the player. So we can see it's moving along with the player here, but in our screen it just looks like it's not moving at all. So it's a handy, simple way to make it look like you've got a lot more depth going on in your game than just having a plain old 2D background. And also one of the other benefits of something like this is that if we were just to have a flat painted wall, the way we have it set up, you need to have a whole bunch of your background objects painted along there. But say with our far hills here now, we can get rid of all of these, and we can hit play, and you're never going to run into those extra bits that we saw there. So as you can see, we're just walking along, and our far mountains are looking off in the distance, and we're not having to use up as many assets and resources. So it's also helpful in that it saves up on the memory of the game being used. So there you go. That's the basics of how to add a parallax system to your game. Like I said, it can be used for many different kinds of 2D games. Basically, wherever you want to create a sense of depth behind the player, you can just do something very straightforward like this. So thanks for watching this episode, and I will be back with more Unity tutorial goodness in the very near future. Thanks for checking out this episode, and if you want even more Games Plus James goodness, make sure you hit those subscribe and like buttons. You can also find me on Twitter and Facebook by following the links on screen, where you can find out all the latest news about the channel. And if you want to help support the show, check out the Patreon page, where you can get exclusive content in return for helping make the channel even better. Thanks for watching, and stay tuned for more.